Hello guys. Today we are going to be talking about quadratic word problems again, and I want you to watch how to do the problems that you actually have already attempted. So this video will help you know how to complete these problems and how to set them up. But before we do all of that, I want to talk about the learning targets, the things that I hope that you can do at the end of this lesson. The first one, you should be able to say, I can understand what the word problem is asking. You've got to understand that or you won't be able to finish the word problem. Also, I can set up the necessary equation. I can solve that equation, and I can state the answer in complete sentence form. All of those things are very important. All right, so I want to talk about number 5. Number 5 is on your worksheet that you already have, and it's the one where you're trying to dunk a basketball, okay? And it says you will need to jump 2.5 feet in the air to be able to dunk the ball. The height that your feet are above the ground is given by this vertical movement function. H of t equals negative 16t squared plus 12t. And it says, what is the maximum height your feet will be above the ground? And then it asks another question, but let's deal with this first question first, okay? So what is your maximum height that the feet will be above the ground? Well, look at this. This is a quadratic. The leading coefficient is negative, so a is negative 16, and that is negative. So that means that this is a quadratic that will open down. Also, there's no c, so that means the y-intercept, actually there is a c, it's 0. So the y-intercept or the h-intercept is actually 0. So it's like this, and you're trying to find what? It says, what is the maximum height? So on this graph, what is the maximum height? It's right here. It's not here, it's not here, it's right here. And we're looking for this h value or y value, and this is time. So this is your plan. I can understand what the question is asking. So remember, that's the first learning target. I can understand what it's asking. The second one is I can set up the necessary equation. So let's do that. If we want this maximum height, we really want the max value. We want the y value or the h value of the maximum point. So we can do that by hand. And what would I do to find a maximum y value? Well, remember there's this thing called an axis of symmetry going right through the middle. And we know a formula for that. It's normally x equals, but we're going to say that is also t because in context of this problem, our x-axis is our t-axis. Negative b over 2a. So back up here, a is negative 16. What is b? It's 12. So I go, all right, negative 12 over 2 times negative 16. And we clean that up. Negative 12 over what? Negative 32. So negative 12 over negative 32. What would that give me? Well, that would give me something like positive 12 over 32, which we can reduce. If you're not sure how, let's keep dividing by 2. We get 6 over what? 16. Keep dividing by 2. We get 3 over 8. We get 3/8. That's wonderful and dandy, but is that what we want? No, that's the t value that this occurs. So we know that this is 3/8, but we need to get the corresponding y value. So to get the corresponding y value of this maximum point, or h value, we've got to plug this back in to the t's. So we're going to do h of 3/8. So negative 16 times 3/8 squared plus 12 times 3/8. You could very easily, well, maybe not very easily, but you can use your calculator for this, or you can do it by hand. I'm going to just type it straight in my calculator. And I hit enter, and I get, I don't know if you can see this, I get 2.25. So that means that this maximum height is 2.25. So right here, this ordered pair is 3/8, comma 2.25. So what is my answer to the first question? It says, what is the maximum height? So the maximum height would be 2.25 because that's the corresponding h value. So the max height is 2.25 feet. Okay, that's fabulously wonderful. Now, the second question, will you be able to dunk the ball? Well, look, we need to jump 2.5 feet, but how high are we jumping? We're only jumping 2.25 feet. So will we be able to jump to the height of 2.5? No, so we won't be able to dunk the ball. I hope that makes sense. Another way you can do this is on the calculator entirely. So this black equation right here, you type that black equation into y1. So you would put this into y1, this is the calculator way. Then you would hit second calc, and you would go to maximum because we need to find the maximum. Then you would scroll Blinky Man to the left of that high point. So Blinky Man might be like right here, and then right here. So, oh, wait a minute, time out. You would take Blinky Man to the left, and then once Blinky Man's to the left, you hit enter. So you go left, enter, and then you move Blinky Man over to the right of that highest point. Once Blinky Man's to the right of the highest point, so you go right, you hit enter, and then through guess, you always hit enter. And that will compute the maximum point for you to be in decimal form. So it would be 0.37, if you round it, comma 2.25, and you can get the answer there. Alrighty. Next, number 6. So you've done this one as well. It says a diver is standing on a platform 24 feet above the pool. He jumps from the platform. Okay, yeah, that's the typo one. We already talked about that. But it jumps from the platform with an initial upward velocity of 8 feet per second. Using this vertical motion formula, which has a V and an S. Remember, S is the same thing as the initial starting point, the initial height, where H is the height above the water, T is the time, V is its starting upward velocity, and S is the starting height, okay? How long will it take for him to hit the water? Okay, so we have a lot going on. The first thing I would want you to do is to rewrite the vertical motion formula. So it would be negative 16t squared plus VT, our V is 8, velocity, so 8t, plus our starting height is 24. So now let's really try to understand what this question is asking. How long? That means they want time. They want a time answer. How long will it take for him to hit the water? So again, quadratic, what's A? A is negative 16. And since that's negative, it opens down. Its starting height is 24. So we're up here at 24 as a starting height, and it goes like this, okay? Now it wants to know how long it takes for it to hit the water, for him to actually hit the water. So he's jumping up, he's going down, and he hits the water right here. So this is a different one from number 5, a different type. We want to know how long it takes to actually hit that water. So what is that? Well, this is the t-axis, this is the h-axis, so this is a t-intercept. A t-intercept, which we're more used to calling an x-intercept, but it's a t-intercept in context of this problem, which means at a t-intercept, you've got h equal to 0. All along this line, your height is 0 because you're hitting the water, okay? You're at level, you're at ground level, so you're hitting the water. So we want our height to be 0. So this right here is going to turn into 0. So 0 equals negative 16t squared plus 8t plus 24 because we want the height to be 0. Now, how will we solve this? There's a couple ways. I want you to actually use your calculator this time. And so I have a specific way I teach this, but just know there are other ways to do this. The way I showed you guys last week was what you do in Y1 is you put the actual vertical motion formula. Now you won't use a T, you'll use your X button. And then in Y2, because we want the height to be 0, I want you to put Y2 as 0. I want you to hit the graph key, and I want you to see if you can find it in the viewing window. You probably won't, because you're probably in a standard window, which is going from negative 10 to 10 on the X and the Y axis. So if you hit zoom 6, that'll get you to a standard window. It looks something like this. You can't see the whole thing, but you can definitely see where it crosses the T or the X axis. So since we can see where it crosses the T axis or the X axis, we can do what we need to do. So we hit second, calc, so second calc, and we go to intersection, because what you just did with this calculator is you had it graph this, and then you had it graph this line. You just may not have seen it unless you have one of those new calculators that does different colors for the different graphs. But it just graphed two lines, okay? And you're going to be finding this intersection point. So you want to go to second, calc, intersect. You hit enter, or however you get there, you can hit 5 or hit enter, and you see where it says first curve, and then you'll see where it says second curve, and guess, I just want you to hit enter 3 times. So enter, enter, enter. So you hit enter, enter, enter. So enter, enter, enter. And it might default to the other side. My calculator's frozen, so I'm going to hit the on button and try it again. Second calc, 5. Enter, enter, enter. And mine defaulted this way. Okay? So I need to start over because I need this one. So right at this point, when I go to second count, intersect, I'm going to do it again. Second count, intersect, but I want to move Blinky Man over to this part. Not over here because time's never negative. We want to be right over here. So I'm going to move Blinky Man to where he's over right as close as I can to the actual intersection point that we are desiring to find. Okay? So I'm doing that, and then once I move Blinky Man there, I hit enter, enter, enter. And I got that this intersection point right here is 1.5, comma 0. 1.5, comma 0. So can we answer the question? Well, yeah. How long will it take for him to hit the water? It'll take him 1.5 what? Will it be seconds, minutes, hours? Well, look up here. It's feet per second. So our time measurement is seconds. So it will take him, the diver, 1.5 seconds to hit the water. Any other questions that this one asks? I don't think so. It just says, how long will it take the diver to hit the water? Okay. I hope that makes sense. I will continue on with some more videos, but that was number 5 and 6 from your homework worksheet.